In this video, we'll show you why automation and control works best with a PC and a microcontroller. The best way for the PC and micro to communicate is USB HID, and the best way to create that is with a smart code generator. Details inside. This video is brought to you by Trace Systems, Inc., the makers of HIDmaker and Simple Upgrade Management System. Download our free guide to USB Success, Secrets of Successful USB Developers. If you bought a word processor program in 1992, you received a box that contained over 20 3.5-inch floppy disks. Only 3 of those disks actually contained the word processor software. All the rest of those disks contained driver software, so the host computer could communicate with all the different kinds of printers available at that time, all the keyboards available at that time, and all the mice available at that time. There were few standards yet, so each manufacturer's software was a little different. In a few short years, the need for the software on all those extra floppy disks was gone, replaced by this Universal Serial Bus, USB, a fast, convenient, easy to use, utterly reliable, extraordinarily flexible system for automatically connecting peripheral devices to computers that works on all desktop and laptop computer operating systems. USB, a standardized system that allows any host computer to automatically discover the types of connected peripheral devices and link each one of them to the right driver software and get to work in seconds. But there's another kind of automation that is happening now all around us. Every day, more and more of the world's machinery is being automated, either just monitored or completely controlled by software. At the low end, even your coffee maker is smart now. Your toaster is now a multi-purpose oven that can roast a chicken faster by also running a fan to blow hot air over the food. At the high end, nuclear power plants have always been monitored and at least partly controlled by software. In the mid-range, it is especially useful to monitor or even completely control hardware from an inexpensive Windows PC. PCs and microcontrollers like PIC processors are each good at doing different things. You need both kinds of capabilities if you want to control hardware. The PC is great at user interfaces, multitasking, communication with the head office, graphics, and sound and video. But a PC is lousy at monitoring every millisecond what a machine is doing because the PC is really busy doing all that other stuff. On the other hand, a PIC Micro is great at spending all its time closely monitoring and controlling a machine and rapidly responding to events and hazards. But an inexpensive microcontroller does not have the memory space for a full user interface. A microcontroller is not very good at high-level thinking or mathematical computation. Now, bigger microcontrollers like PIC32 processors can support a full user interface, but it takes extra memory and development time, which is more money, to make and debug a built-in user interface. And the user interface you can make on a micro will be very primitive compared to what a full PC can do. For a lot of monitoring and control applications, the best combination is an inexpensive Windows PC that talks to a microcontroller. The microcontroller has the direct connection to the machine and performs the detailed millisecond by millisecond monitoring and controlling of the machine by executing commands sent from the PC. The PC does the high-level thinking, decision-making, communicating with the microcontroller, graphical user interface, mathematical calculations, and communication with the head office over the internet. Which brings us to consider how the PC should communicate with the microcontroller. The obvious choice these days is USB, but what kind of USB? The obvious choice of what kind of USB should be Human Interface Device or HID class. It's fast enough for most control applications. Full speed can send and receive up to 64,000 bytes per second. It's available on all desktop and laptop computers. It's highly reliable with built-in error checking. It does not require any special device drivers to be installed by you. The data is completely self-describing, and it can even provide multiple data channels that you can run simultaneously. If you can do HID right, HID can do a lot for you. But a lot of people, apparently even the compiler manufacturers, don't appear to know how to do HID right. That's why we developed HIDmaker, which uses a third kind of automation, code generation. You see, I used to really struggle with USB myself until I realized two things. Thing number one was the very things that make USB easy for users to use are the same things that make USB hard for designers to design. Thing number two was, since USB software is meant to communicate with a computer, then the best way to create USB software is to generate that source code in a computer. That's the best way to get all the many details right on both the host computer and the peripheral side, consistent on both sides, at the same time. Now, there are some folks who flatly say code generators are all bad. I would say no, only dumb code generators are bad. If you are even an occasional part-time software developer, you are getting the benefit of smart code generators every time you start a new project. Every competent integrated development environment, or IDE, that you find, from Microsoft Windows, Visual Studio, and Delphi Rad Studio for Windows, or Apple's Xcode, or Microchip's MPLAB and MPLAB X for PIC microcontrollers, or Eclipse for lots of things, all of these will generate some rather complicated source code that defines your new project. Next time you get a chance, take a closer look at those project files. They are complicated and they can be big. If you had to create those yourself on a blank page from a set of instructions in the IDE's help files, then starting each new software project would be a slow, painful, and very error-prone operation, one that you could quickly come to dread. No, only dumb code generators are bad. HIDmaker's code generators are very smart and very detailed, so they can generate matched custom source code for both your choice of PC compiler and your choice of PIC microcontroller compiler. Heck, if you want, you can even generate code for all the compilers we support. And that's why we have happy customers all over the world. Those developers can quickly use HIDmaker to define the transfer data items that get sent over USB, arrays, or single variables that can range in size from 32 bits down to one single bit or anywhere in between, and generate code that compiles and runs and communicates correctly in as little as 10 minutes. And that code works end to end, guaranteed. So here's the bottom line. The pandemic is ending and the economy is going to surge in a few months. That will create tremendous opportunities for all of us. If you are not taking advantage of all these three forms of automation and making use of the efficiency that this gives you, then the world is very likely going to pass you by. Question of the day. What is one of your biggest challenges in making USB projects and getting them to actually work? Put it in the comments below so I can help. Thanks for checking out this video. Please subscribe if you're not already subscribed. If you want to, check out that free Secrets of Successful USB Developers guide with tips on getting your USB projects working end-to-end, really fast, every single time. Click or tap the screen in the description below. As always, we're helping you build your knowledge, skills, and impact with online video. Talk to you soon.